This video is for standard algorithm of multiplying decimals. So the standard algorithm for this is a little bit different than the standard algorithm for multiplying whole numbers. And the reason that it's different is because you do not have to line up place value. So I'm going to give us a problem that we should already know the answer to. 1 5/10 times 2, we know that $1.50 plus $1.50 should be $3. So this should be our answer. Alright, so we're going to go ahead and start. So with standard algorithm for multiplying decimals, it calls for you to push everything all the way to the most right side. So that's what I did. Even though this 2 is actually in the ones place, I still put it under this 5 that's in the tenths place because of what standard algorithm calls for. If we were adding it, of course, I would have to push it over to the ones place and line it up. Okay, so we're going to start off just like you do with standard algorithm for whole numbers. You start with this base number right here, and you multiply up, and then you keep going to each of the numbers. So 2 times 5 gives me 10. Carry that 1, just like before. 2 times 1 is 2, plus 1 is 3. So I have 30 here. So now what standard algorithm calls for you to do, you look at your problem and you count how many numbers are behind your decimal point. I have one number behind a decimal point, and it's this 5. So since I have one number behind a decimal point, I'm going to keep one number behind the decimal point. So that determines where my decimal point goes, and we got the same answer that we said the answer should be. Okay, so why does this work? This works because multiplication, you would be multiplying that number by each number anyway. So let's work it again. Let's go ahead and put the 2 here. So we're going to have 2.0. So I'm going to go ahead and solve this out. 0 times 5 is 0. So we know from standard algorithm that when you have a 0 in this place, you can scoot over, because each time you do this, you're just going to keep getting 0, 0, 0, 0, 0. So I'm going to go ahead and do that. Now I'm going to move to my second number. 2 times 5 gives me 10. Carry the 1. 2 times 1 is 2, plus 1 is 3. So now I have 300. Well, I actually added another number here. That's why I got an extra 0. So now I'm going to go back and I'm going to count how many numbers I have behind the decimal point. I have 1, 2. Since I have 2 numbers behind the decimal point now, I'm going to say 1, 2. There's my decimal point. My answer is still 3. That's why it works. Standard algorithm is keeping you from adding all the zeros in that you need if you were going to line up each place value. But the reason is because you're still multiplying by each number. And since you're doing it anyway, there's no point in really lining up the place value, as long as you count your decimal places. Why does it work for you to count your decimal places? Let me show you. Alright, so let's say we have 3. I don't know why I keep choosing 3s and 2s. It's just a thing I do. Okay, so I'm going to do 3 and 321 thousandths times 42. So these are very different numbers. This one has a tens place, and then this one has many decimal places that this one doesn't have. I'm going to go ahead and multiply these out. This is kind of sideways. It might look like a addition sign. Okay, so I'm going to go ahead and multiply these out, and we're going to see if it still works by counting up the decimals. So I have 2 times 1, that gives me 2. 2 times 2 gives me 4. 2 times 3 gives me 6. And 2 times 3 gives me 6 again. So I'm finished with my 2, I'm going to move on to my 4. Sorry, I was looking for my purple marker. Okay, so now I'm going to put a 0 here, because now we know that it's 40 times 1, or 40 times 1,000th, but 4 times 1 gives me 4. 4 times 2 gives me 8. 4 times 3, that's 12. I'm going to carry that 1. 4 times 3 is 12 again, 13. Okay, so now I'm going to add all of these together. So I get 2, 8, 14, 9, 3, 1. Okay, so now where do I put my decimal point? So I have 1, 2, 3 numbers behind the decimal point. So I'm going to go ahead and put my decimal point right here. We cannot just bring the decimal point down. So I counted 1, 2, 3, and I put it here. So now let's check and make sure it seems plausible. So to the side, I'm going to say, what's 42 times 3? So 3 times 2 is 6, 3 times 4 is 12. Okay, so I got 126 for 42 times 3. Does 139 seem plausible? Yes, it does, because we have some extra decimal places back here that we are multiplying by. Okay, so this does seem plausible. It is close. So why does it work for you to just count how many decimal places? It's because that's how many decimal places you started the problem with. So you're not going to have more decimal places unless this number has decimal places as well. Always remember, a fraction times a fraction is a smaller fraction. A decimal times a decimal is a smaller decimal. And we know that the more decimal places a number has, the smaller the number. When you multiply a 1-digit number by a 1-digit number, you're never going to get more than a 2-digit number. So when you multiply a number that has 3 decimal places by a number with no decimal places, it's not going to have more than 3 decimal places. If you multiply a number with 3 decimal places against a number with 3 decimal places, your number is going to get much smaller. So it's going to have 6 decimal places going back, because that's how many decimal places you multiplied together.